Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Combined Science Physics Paper 1 Higher Tier from 2023. Question number 6 is on the topic of particle model of matter. Figure 12 shows a device that uses a mug of hot coffee to turn a wheel. The hot coffee increases the temperature of the air in the chamber. Explain how the pressure in the chamber increases. Now, if the temperature increases, the pressure should increase. That should give you a mark. Let me get it a straight line. So if the temperature increases, the pressure should increase. The reason is the air particles will move faster. If the temperature increases, the air molecules will move faster with increased kinetic energy. That means there is going to be more collision between the walls of the chamber, right? That increases the pressure because there's more force per square unit area. So here's a standard answer. Air particles move faster, or you could say the air particles have increased kinetic energy. So the air particles collide more frequently with the wall of the chamber, or the air particles collide with more force with the wall or the chamber. So the pressure increases. Remember, pressure equals force over area. So if you increase the force, you increase the pressure. For this device to work, the air in the chamber must increase in temperature quickly. Explain why the bottom of the air chamber is made of metal rather than plastic. Now, metals are better conductors, thermal conductors than plastic, so it allows a greater rate of energy transfer. So metals have a higher thermal conductivity, which allows a greater rate of thermal energy transfer. The mass of the air in the chamber is constant. What property of air allows a small change in the internal energy to cause a large thermal energy change to the air in the chamber? Now, the question is saying what property of air, something like density, thermal conductivity, and so on. What property of air allows a small change in internal energy? So we are talking about a temperature change. Or internal energy in terms of movement of molecules causes a large temperature change to the air in the chamber. That would be a low specific heat capacity. Because air has a low specific heat capacity, you don't need a lot of temperature change, or you don't need a lot of energy change for the temperature to change. The changes in pressure in the air chamber causes the wheel to turn. Suggest one way to increase the speed at which the wheels turn. You could lubricate the wheel, or you could increase the temperature of the coffee, or you could decrease the temperature of the surroundings. Any of those will give you a mark. 6.5. The temperature of the coffee decreases as the device is used. The initial temperature is 76 degrees Celsius. The internal energy of the coffee decreased by 15 kilojoules. Let's change that to joules. So that would be 15,000 joules. That should give you a mark. Density of the coffee is 1.1 times 10 to the power 3 kilogram per meter cube. Volume of the coffee is 1.9 times 10 to the power minus 4 meter cube. So because they have given you the density and the volume, you will need to find the mass using the equation for density. Density equals mass over volume. The specific heat capacity of the coffee is 4,200. Calculate the final temperature. final temperature. So let's calculate the mass. Density equals mass over volume. So mass equals density multiplied by the volume. Density is 1.1 times 10 to the power 3 times 1.9 times 10 to the power minus 4. That would give you a mass of 0.209 in kilograms. So using the equation for specific heat capacity, the energy transferred equals the mass multiplied by the specific heat capacity multiplied by the temperature change. So 15,000 equals 0.209 multiplied by 4,200 times the temperature change. Rearranging the equation, temperature change equals 15,000 divided by 0.209 times 4,200. That gives you 17.088 degrees Celsius. Now remember, 17.088 is the temperature change. So in order to find the final temperature, remember initially the temperature was 76. So we take away 17.088. That gives you rounded 59 degrees Celsius. That brings us to the end of this question and to the end of this paper. Thanks for watching. I will see you in the next video.